Good evening, dear students. Today we are going to discuss matrices. Before I start, please let me know that all of you are able to view the screen properly and you are able to hear my statement very clearly. Any one or two students can say yes, that is fine.
Yes, sir.
All right.
Yes,
All right. Thank you
sir.
very much. You no need to answer then. Okay, great. I got a confirmation from a couple of students. Not all student has to say yes. Okay, thank you very much. So this is a very important topic. First, let us understand, dear students, that what is the justification or what is the motivation we should learn matrices. Okay. The first and foremost thing is that let me give you a few examples that will help you to understand that why we should learn matrices. And we will see in the next couple of minutes that it has immense application not only in the field of mathematics, but in other fields. So from the field of mathematics, let me tell you that you have been given a system of linear equations like this. If you see the system of linear equations, what is x1, x2, x3? x1, x2, x3, these are the unknowns, the variables. And what is your task? Your task is to find the values of x1, x2, and x3. Now, the concept of matrix is helpful to find the value of x1, x2, and x3. This is one example where matrix is useful. Apart from that, it has immense application in statistics in real-life problems. So statistics can be defined as a type of mathematical analysis which involves the method of collecting and analyzing data and then summing up the data to a numerical form or a given set of factual data or real-world observations. So in our daily life, we collect information and that helps us in resolving questions regarding the world in which we live. That is statistics. So in statistics, there are immense application of matrices. In physics-related applications, matrices are used in study of electrical circuits, quantum mechanics, and optics. Engineers use matrices to model physical systems and perform accurate calculations needed for complex mechanics to work. So this is
some applications from physics. It is immense applications in graphic software design. Okay, so more than.
Sir, your voice.
I'm sorry, my voice is not clear.
Now it's a little better.
Okay, is it okay, sir? Fine now?
No, sir.
Is it fine?
Yes, sir.
Okay, all right. So what I was telling is that in graphic software, for example, the Photoshop application, what you have in your computer, uses matrix to process linear transformations of render images. So in brief, what I can say is that matrix has, extensive applications used to solve real world problems. Now let's come to, the abstract, mathematics, and let's understand what is represented by matrix. Okay, a set of m by n numbers. So let me first show you, and then you are able to view it. Dear students, please one or two students can confirm. You able to hear my voice clearly?
Yes, sir.
Yes, sir.
Yes, sir.
Great. Not everyone has to tell, dear students. Okay, great. Thanks. One student or two students saying is fine, because there are so many students. If all of you start saying yes, then it will be a little bit of time consuming effort. So a set of m by n numbers, it could be real or complex, arranged in m rows and n columns is called a matrix of order m by n. So for example, if you see, there are m into n numbers, okay, arranged in this manner. In this row, if you see, this is the first row where the numbers are A11, A12, A13 up to A1n. Then it comes the second row where it is the numbers are A21, A22, A23 up to A2n. Then it comes the third row, and what is there? This is, third row elements are A31, A32, A33 up to A3n. And in that way, it proceeds up to the mth row. And mth row elements are AM1, AM2, AM3 up to AMN. So what you see, dear students, that there are m rows. What you see here? There are m number of rows. And in each row, there are n elements. So obviously, there are total number of elements is m into n. In the same manner, we can see that this is the first column. In the first column, what are the elements? A11, A21, A31 up to AM1. Then the second one is that A12, A22, A32 up to AM2. In that way, we go for the, a second row, second column, third column. In that way, go up to the nth column. So what we see here, so this is actually, n columns. So what we get, it is an m rows and n columns, and that is why it is called an m by n matrix. It is known as an m by n matrix. So a matrix of order m by n is having m rows and n columns. And from here what we can say, that any element is that we can denote it by aij, that subscript. What is that I and j stands for? Here I can vary from, where we can say that I can vary from 1, 2 up to, it can vary till m, and j can vary from 1, 2, ... up to n. So in that way also you can represent a number that is called aij. That is, it is a aij is an element in that matrix in the ith row and jth column. For example, if we consider this particular elements A23, here you can say this element A23 positioned at the second row and third column. That means if you go with the second row like this and the third column, then you'll find that intersection of second row and third column is actually the position of the elements A23. Now, what we are going to discuss, the next point is that we denote these matrices generally capital letters. Okay, for example, we can denote a matrix, like that. Let me define 3 matrices here, and it will help you to understand that exactly how matrix is actually being represented. If you see here, dear students, that matrix A is having 3 rows and 2 columns. What are the 3 rows? These are the 3 rows. This is the first row containing the element -2 and 5. Second row containing the element 0, square root of 5. And this is the third row containing the element 3, 6. Then this is the first column containing the elements -2, 0, 3. And this is the second column containing the elements 5, root 5, and 6. In the same manner, you can see, dear students, that the matrix B has 3 rows and 3 columns. Matrix C has 2 rows and 3 columns. So whenever you see the matrix is denoted by A, 3 by 2, it actually says that by looking into the 3 cross 2, you can say that matrix is having 3 rows and 2 columns. So this is the way the matrix is actually represented generally with the capital letter. Now, what we're going to discuss next point is that the order of a matrix. Okay. The order of a matrix with m rows and n columns is a matrix of order m by n. So how we denote this thing? We denote this thing something like this. The order of a matrix. A matrix with m rows and n columns is known as a matrix of order m by n or m cross n. If you look into these three matrices, A, B, and C, we can just by observing the matrix A, we can say the order of the matrix A is 3 by 2 or 3 cross 2. Why? Because the matrix A is having 3 rows and 2 columns. Matrix B, it is having 3 rows and 3 columns, hence it is known as a matrix of order 3 by 3 or 3 cross 3. Matrix C is having 2 rows and 3 columns, hence it is a matrix C is of order 2 by 3 or 2 cross 3. So as I was telling that, the notation by which we can, symbolically represent a matrix is something like this, is that if you look into it, the notation, A, ij m by n or m cross n, as you see, dear students, that notation A is equal to A ij m cross n is to indicate that the matrix A is of order m by n and its element at the ith row and jth column is denoted by Aij. If you notice, dear students, that Ij are the subscript. It is little below of the starting of the letter A. Means if I say A like this thing, I and J are coming near to the bottom of A. So it says that it is the element, the Aij is the element in the ith row and jth column. That means along the ith row, if you draw a straight line, and along the jth column, if you draw a straight line, so this should be a perpendicular straight lines, and the intersection of those two straight lines is the position of the element Aij. Correct, now, dear students? For example, if you look into this matrix B, if I use a different color, matrix B, if we want to find 2, what is 2? It is an element, we can say, is that intersection of the second row and the third column. The second row and third column, if you intersect, whatever the element you are getting, that is 2. And symbolically, we can represent this as A 2, 3. This element. We can symbolically represent as that A 2, 3 because it is in the intersection of second row and third column. Correct, now, dear students? So now, our next point of discussion is that, we are going to construct a 2 by 2 matrix whose elements is given in some form. Let us see. For an example, let us construct a 2 by 2 matrix whose ijth element is given something like this. So construct a 2 by 2 matrix, okay, whose elements are given as Aij is equal to mod of I minus 5j by 2. Mod of I minus 5j by 2. That is we are going to find it out. How to find out, dear students? Now, as it is a 2 by 2 matrix, so it has 2 rows and 2 columns. So how the matrix will looks like? If we name this matrix as A, then how the matrix will looks like? The matrix will looks like something like this. Is that A is equal to, it should be something like this: A11, A12, A13, sorry, A21, because it is a 2 by 2, A21 and A22. This is the matrix, what we see here, that A11, A12, A21, A22. Now, how we are going to find the value of A11? Okay, the value A11, what we are going to find is something like this. A11 should be what? According to this definition, A11 is going to be mod of 1 minus 5 into 1 divided by 2. That is equal to what? Mod of minus 4 divided by 2. And as you know, dear students, mod of minus 4 is 4. So it is 4 by 2 and we get the value is 2. Similarly, we can get the value of A12. And how we are finding the value of A12? That is equal to mod of 1, because I here is 1 and j is 2. So 5 into 2 mod divided by 2. So that is equal to what we are going to get, dear students. 1 minus 10, that is mod of minus 9 divided by 2, and that is equal to 9 by 2. Then we get the next element is A21. A21 will be what, dear students? Is that mod of 2 minus 5 into 1 divided by 2. That is equal to mod of minus 3 by 2. Correct, not, dear students? Mod of minus 3 divided by 2. And we know mod of minus 3 is 3. That is equal to 3 by 2 finally. Those who are not able to understand what is the definition of a modulus function, I can tell you, dear students, mod of x is equal to, I write a different color, mod of x is equal to x if x is greater than 0. This is equal to 0 if x is equal to 0, and mod of x equal to minus x if x is less than 0. Now let's come back to our finding the different values. So A21 we found is 3 by 2. Next one is A22. A22 is equal to what? It is the mod of 2 minus 5 into 2 divided by 2. And that is equal to mod of 2 minus 10. Mod of 2 minus 10 means mod of minus 8. Mod of minus 8 by 2. So mod of minus 8 by 2 is nothing but 8 by 2, which is nothing but 4. So what are the different 4 elements we got, dear students? A11 is 2, A12 is 9 by 2, A21 is 3 by 2, and A22 is 4. So we can, from here, we can construct that matrix something like this. A is equal to, is that 2, 9 by 2, 3 by 2, and 4. Correct, dear students? So this is the way we can construct a 2 by 2 matrix whose elements are given as Aij is equal to mod of 1 minus 5j divided by 2. Now, the next point what we are going to discuss, dear students, is that, a matrix of order m by n has elements, m into n. So a matrix of order m by n or m cross n is having m into m number of elements. Okay, so we can also work out a small problem related to that. Is something like this, dear students. If you look into the, the statement here, what I wrote is that a matrix of order m into n is having, m into n elements. A matrix of order, I repeat, dear students, a matrix of order m cross n has m into m number of elements in it. For example, there is a small question here. A matrix has 9 elements. What are the possible orders it can have? We need to find all the possible ordered pairs of the natural number whose product is 9. So what are those? 1 and 9, their product is 9. 9 and 1, their product is 9. And 3 and 3, this product is 9. So we can have 3 possible orders of matrices so that it can have 9 elements. The first one will have of order, suppose if I name the first matrix as A, it can have order 1 cross 9. That means it is having 1 row and 9 columns. Second matrix, if I give as B, it can be, its order is 9 cross 1. That means it has 9 rows and 1 column. And the third one, if I name that matrix as C, it has order 3 cross 3. That means it has 3 rows and 3 columns. Now, the total number of rows and total number of columns, if you multiply together, you will get the total number of elements in the matrix. So a matrix of order 1 cross n, 1 cross 9 are going to have 9 elements. A matrix of order 9 cross 1 is going to have 9 elements. And also a matrix of order 3 cross 3 is going to have 9 elements. Correct? Now, what we are going to learn, dear students, is that different types of matrices. So, based on the different types of matrices, we have, different naming conventions, and that we are going to learn now. So, types of matrices is the next point of discussion. So, for example, if you see, dear students, a matrix is said to be a column matrix if it has exactly one column. Okay. For example, let me give you an example of a column matrix. Let me use a different color. A column matrix is something like this. If it has exactly one column, it's something like this. Suppose I write 4, 1, 0, 3. So this is a matrix having 4 rows, but exactly one column. A matrix is said to be a column matrix if it has exactly one column. If you see, dear students, one example what I give is that a matrix having only one column, and in that column the elements are 4, 1, 0, 3. In the similar manner, we can say a matrix is a row matrix if it had exactly one row. Let me show you an example of a matrix which is a row matrix. It's something like this. If we consider a matrix something like that, 5, 1, 7, 3, minus 1. If you see, it is having only one row. It is having 5 columns, that is different. But as this matrix is having exactly one row, we say this matrix is a row matrix. So before we conclude, before we proceed for the next steps, what I can say, dear students, a matrix is said to be a column matrix if it has exactly one column, and a matrix is said to be a row matrix if it has exactly one row. Now, the next terminology is called a square matrix, and which is a very important part of the matrix. And square matrix has immense, importance, and we will see, as time goes by, that square matrix how much important it is. A matrix is said to be a square matrix if it has same number of rows and same number of columns. That means a matrix, let me give you an example of a square matrix. A square matrix example could be something like this. Okay, is something like this: 2, 5, 1, 9. You see here, dear students, the number of rows is 2, which is equal to the number of columns, that is also 2. In the first row elements are what? 2, 5. Second row elements are what? 1, 9. What are the elements in the first column? 2, 1. And what are the elements in the second column? 5, 9. As the number of rows is equal to the number of columns, we can define this matrix as a square matrix. And another example could be, we can have, example something like that: x, 2x, 3, 5, minus x square, 9, 3, 3, 4x. If you look into it, this is also a square matrix. Why? Because this is having the number of rows is 3 and number of columns is 3, both are equal. Hence, it's qualified to be named as a square matrix. The next terminology what we are going to discuss, dear students, is called a diagonal matrix. A matrix is said to be a diagonal matrix if two conditions are going to be true. The first condition is that it has to be a square matrix and all its non-diagonal elements are 0. Let me give you an example. Let me first define and then I will give you an example so that you completely understand what is meant by a diagonal matrix. A matrix is said to be a diagonal matrix if both the following conditions are true. What is the first condition? First condition is that, it is a square matrix. And the second condition is that all its non-diagonal elements are 0. Let me explain you what is meant by its non-diagonal elements as 0. Let's understand with an example because things become very clear when we give an example. So, if you look into this particular one, which I'm going to show you now, dear students, is something like this. You see, if you look into it, it is a square matrix. The number of rows is 4 and number of columns is also 4. As the number of rows is equal to the number of columns, it is a square matrix. The first condition is actually being true. And what is the second condition? Second condition is that all its non-diagonal elements. So this is the diagonal element. This is the diagonal one. Diagonal, you know. And apart from all the elements are non-diagonal. So see, this is 0. So this particular, if you see, these elements are 0. And here also, if you see, these elements are 0. Correct? So then if both the conditions are actually holding true, then we can say this is a diagonal matrix. So I repeat, students, a matrix is said to be a diagonal matrix if both the following conditions are true. The condition 1 is that it is a square matrix, and condition 2 is that all its non-diagonal elements are 0. Now, dear students, what we are going to discuss is that, a symbolic representation. So suppose we have a square matrix Aij, which is written as n cross n, because the number of rows and number of columns are equal. Then what we can write is that we can write that matrix as Aij. That matrix name is capital A, but if you see its elements are lowercase aij, n cross n. So that is a square matrix. And its diagonal elements are actually, non-zero, but non-diagonal elements are 0. So how to represent that? Aij is equal to 0 if I is not equal to j. Let me give you an example. Suppose we construct a matrix, Aij of 3 by 3. So what will be its elements? If we write in a very elaborate way, A11, A12, A13. That is the first row. Second row is A21, A22, A23. And third row is A31, A32, A33. That is the third row. Now, what is the condition for our diagonal matrix? Let me use a different color. The condition for a diagonal matrix, first condition to satisfy it is a square matrix. And all these elements, what I'm saying, circling with the blue color, all these elements has to be 0. Now, if we look into, dear students, that elements what I am encircling with the blue, if you see here, the subscript are actually not equal. Here it is what? A12, 1 is not equal to 2. Here it is A13, 1 is not equal to 3. Here it is A23, where 2 is not equal to 3. Here A21, 2 is not equal to 1. Here A31, 3 is not equal to 1. And finally here A32, where 3 is not equal to 2. And that is why this statement is given. Aij equal to 0 if I is not equal to j. But if I is equal to j, what? Then it cannot be 0. Which is this elements? Let me use a different color here. If you look into A11, A22, A33, in all these cases, the subscript, are same. 1, 1. A1, 1 means 1 is equal to 1. A2, 2 means if I encircled in the green one, A1, 1, A2, 2, and A3, 3. In all these three elements, dear students, if you see that the subscripts are same. A1, 1, 1 equal to 1. A2, 2, 2 equal to 2. A3, 3, 3 equal to 3. And these elements, that is A11, A22, A33, that cannot be 0. And that is actually coming from the fundamental definition of the diagonal matrix. What is the fundamental definition? One of this is that all its non-diagonal elements are 0. That means diagonal elements are non-zero. So all the diagonal elements are 0. Correct, no? Got it? Absolutely clear? Now we are going to discuss the next point, which is called a scalar matrix. Okay. So scalar matrix is a more constrained version of a diagonal matrix. A matrix to be qualified to be called as a scalar matrix, first it has to be a diagonal matrix. And second thing is that all its diagonal elements has to be equal. Okay, dear students. So how we can represent? We can represent something like this. Let me show it to you first, and then I will explain further. If you see, dear students, a matrix is said to be a scalar matrix. A matrix is said to be a scalar matrix if both the following conditions are true. What is the first condition? First condition is that it is a diagonal matrix. Diagonal matrix is what? It has to be a square matrix, and all its non-diagonal elements has to be 0. And second condition is that all its diagonal elements are equal. So symbolically, how we can represent? Symbolically, you can say that if the matrix is represented by capital A with symbolic representation as lowercase aij n cross n, then what is the property of aij? Aij is defined something like this. Aij should be equal to 0 if I is not equal to j. That constitute I is not equal to j means what? We are choosing all the non-diagonal elements. And if I equal to j, then it all has to be equal. Suppose we are assuming this is k, that if I is equal to j, and k is some constant, then we can say this is a scalar matrix. So what is a scalar matrix? Scalar matrix has to be satisfied with two conditions. The first one is that it has to be a diagonal matrix, and second one is that all its diagonal elements has to be equal. Let me give you an example so that things will be much more clear to you. So one such example of a scalar matrix is something like this. I'm going to show you this example in few seconds. Yes, it is available in front of you, dear students. So if you see, dear students, all the diagonal elements are equal and equal to 3. As I draw this straight line, and it crosses all the diagonal elements, and all these diagonal elements equal to 3. For example, as I defined aij equal to k, if I is equal to j, that means here k is equal to 3. And if you see, dear students, all the non-diagonal elements, all these non-diagonal elements are actually 0. So this is non-diagonal elements 0, and this is also non-diagonal elements 0. Correct, dear students? So from here we can say this is a scalar matrix. So to have a matrix to be qualified to be a scalar matrix, definitely it has to be a diagonal matrix. On top of it, all its diagonal elements has to be equal. Now, the next definition what we are going to do, dear students, is called an identity matrix. An identity matrix has immense application. Okay. A matrix is said to be an identity matrix if two conditions are true. First is that it has to be a diagonal matrix. And second one is that all its diagonal matrix has to be equal to 1. That means what? If I define in a symbolic representation and in both in English word. It's something like this. A matrix is said to be identity matrix if both the following conditions are true. The first one is that it is a diagonal matrix. The moment the statement is there, it is a diagonal matrix, it means that it is a square matrix. Okay, and all the non-diagonal elements are 0. And the second one is that what we can say is that diagonal elements has to be equal to 1. Or in other way, you can say that a identity matrix is a scalar matrix where all the diagonal elements is equal to 1. So how we can symbolically represent? If we define the matrix as capital A with its elements as lowercase aij, so what we see, aij is something like this. This is equal to 0 if it is a non-diagonal elements. Non-diagonal elements means what? I should not be equal to j. And this is equal to 1 if I is equal to j. That means it represents the diagonal elements. Let me give you an example. For example, a diagonal matrix, an identity matrix is something like this. And I repeat, dear students, the statement what I said few minutes back, that identity matrix has immense application. It is an important one. We'll see it has immense application in finding the inverse of a matrix, finding the solution of the system of linear equations, and etc. So this is a classical example of an identity matrix of order 4 by 4. Okay, so this we are done with the identity matrix. Our next point of discussion, dear student, is called a zero matrix or null matrix. So let us define what is a zero matrix or null matrix. A matrix is said to be a zero matrix or null matrix if all its elements are 0. And there is no restriction on whether it has to be a square matrix or not a square matrix. Any matrix in which all the elements are 0, then we can tell this matrix is a null matrix or zero matrix. Let me give you an example so that it will be very clearly understood. Here is the example, dear students, I'm going to show you. A matrix is said to be zero matrix or null matrix if all elements are 0. A matrix is said to be zero matrix or null matrix if all its elements are 0. For example, if you see the example what I'm showing it to you, this is a matrix of order 4 by 3. It has 4 rows and 3 columns, not a square matrix, but as all its elements are 0, it qualified to be called as a zero matrix or null matrix. Now, so with this, I'm done with the definition of different types of matrices. And now what I'm going to discuss, dear students, I'm going to discuss about the equality of two matrices. How, under what condition we can say that two matrices are equal. Okay, now let's see equality of matrices. If you see, dear students, the equality of matrices, the definition I give like this. Let A, capital A, which is symbolically represented by elements as Aij. Okay, this is one matrix. And another matrix is that capital B, symbolically represented at Bij, be two matrices. Now, this A and B are said to be equal if the following two conditions are true. Number one, the order of the matrix A is equal to the order of the matrix B. That means the number of rows and columns in the matrix A has to be equal to the number of rows and columns in the matrix B. Or in other way, I can say more elaborately, the number of rows in the matrix A has to be equal to the number of rows in the matrix B, and number of columns in the matrix A has to be equal to the number of columns in the matrix B. That is the first condition. And the second condition is that Aij should be equal to Bij for each and every possible values of I and j. That is, each element of A is equal to the corresponding element of B. Let me show you an example so that it will be very clear to you. So for example, these two matrices, one example I'm going to show here the two matrices are equal, and another matrix I'm going to show where they are not equal. So look into here. The matrix, 5739 and 5739 are equal because both the orders are same, this one and this one. And if you see the corresponding elements of the matrix, left-hand matrix and the corresponding elements in the right-hand matrix are same. Whereas so this is a classical example where the two matrices are equal. But if you see the second one, these two matrices, that is 5739 and 7739, are not equal, despite the order of these two matrices are same. Why they are not equal? If you look into the element in the first row, first column of the first matrix is not equal to the element of the first row, first column of the second matrix. In the left-hand side, the first row, first column matrix is element in the first row and first column is 5. Where in case of the right-hand side matrix, the element in the first row and first column is 7. Obviously, 5 is not equal to 7. Hence, these two matrices are not equal. As it is written here, are not equal. Clear, dear students? So, what is meant by the equality of matrices? Now, let us solve the problem together. You can also open your notebook, and I'm also explaining so that you can relate the way I'm actually solving a problem. So here is the exercise. All of us will, solve together. So let me first, place that exercise. Here it is. The question is that, the first matrix is A. It is a 2 by 2 matrix. Elements are x plus y, y minus z, 5 minus t, and 7 plus x. And another matrix is B, dear students. It is also a 2 by 2 matrix. What are the elements? T minus x, z minus t, z minus y, and x plus z plus t. Now, it is, if these two matrices has to be equal, what are the values of x, y, z, and t? That is the task we are going to perform now. All of us. You can also, as I said, you also open your notebook. So what is the question? Question is that if A is equal to x plus y, y minus z, 5 minus t, 7 plus x, as you see here, this is A. And B is t minus x, z minus t, z minus y, and x plus z plus t are equal, find the values of x, y, z, and t. Now, dear students, how we are going to solve it? We know, just we learned that two matrices are equal, are said to be equal if their orders are same, which is true here. The order of the matrix A is 2 by 2, order of the matrix is B is 2 by 2. So the first condition hold true. And what is the second condition? The corresponding elements in both the matrices has to be same. So according to that statement, what we can say? We can say that x plus y is equal to t minus x, correct or not? X plus y is equal to t minus x. Now, as x plus y is equal to t minus x, From here, what you can find the value of 2x. So from here, we find the value of 2x is equal to t minus y. So t minus y. This implies the value of x is equal to t minus y by 2. T minus y by 2. So let me give this as equation 1. Now let's come to the next one. In the next equality, that y minus z, which is the element in the intersection of first row and second column of the matrix A, has to be equal to the corresponding elements in the matrix B, which is z minus t. So y minus z has to be equal to z minus t. So y minus z has to be equal to z minus t. Now from here, what we can find? From here, we find that 2z is equal to y plus t. So from here, what we get is that x is equal to t plus y by 2. Sorry, z is equal to t plus y by 2. Now let's give this as equation 2. Correct, dear students? So we get equation 2. Now let's take the other one, that is 5 minus t. The element 5 minus t is equal to the elements z minus y of the matrix P. Because 5 minus t is the element, as you see, dear students, it is the intersection of the second row and first column of the matrix A, and the corresponding element in the matrix B is z minus y, which is in the intersection of the second row and first column of the matrix B. So what we can write, 5 minus t is equal to z minus y. So 5 minus t is equal to z minus y. Now from this, what we are going to get? 5 minus t is equal to z minus y. So z is equal to y minus t plus 5. So z is equal to y minus t plus 5. Correct, no, dear students? So this we are giving an equation 3. Now let's come to the last one. 7 plus x, which is the element in the matrix A, which is in the junction of the second row and second column, and corresponding elements in the matrix B is x plus z plus t. So what we are going to write? 7 plus x is equal to x plus z plus t. And that implies what? That implies 7 is equal to z plus t. 7 is equal to z plus t. And from here, we get the value of z as 7 minus t. So we get the value of z as 7 minus t. Let's give this as equation number 4. So far, dear students, we got 4 equations. The first one, x is equal to t minus y by 2. Second one is z is equal to t plus y by 2. Third one is z is equal to y minus t plus 5. And the fourth one is z is equal to 7 minus t. Now let's focus on the equation 3. From equation 3, what we are going to get? Z is equal to y minus t plus 5. Correct or not? So from equation 3, so let me do it here. And let me do it in a different color so that you can make a difference. So from equation 3, what we are going to get? We are going to get z is equal to y minus t plus 5. Z is equal to y minus t plus 5. Now, if you look into equation 4, what is the value of z? 7 minus t. So the value of z, which is 7 minus t, we can bring it here. So what we can write? This implies z is equal to 7 minus t is equal to y minus t plus 5. So from here, what you get? The value of y is 2, because 7 is equal to y plus 5. So from here we get 7 is equal to y plus 5, and that implies y is equal to 7 minus 5, that is 2. Good. That first value we got, y is equal to 2. Now, the moment we find the value of y is equal to 2, we can apply that value in the equation 2, dear students. Correct, no? If we apply in the equation 2 the value of y is equal to 2, then what we are going to get? Let me use a different color here. So from here, what we are going to get? Here, if I apply the value of y is equal to 2, so what we are going to get? We are going to get z is equal to t plus 2 by 2. Z is equal to, sorry, let me write properly. Z is equal to t plus 2 divided by 2. Correct, not dear students? Now, as we get z is equal to t plus 2 by 2, and let's now focus in the equation 3. What is the value of z? Z is equal to, in this equation, we can apply the value of z. In this equation, if we apply the value of, let me use a different color. Oh, that's fine. This color is also fine. So what we get, the value of z is equal to y minus t plus 5. So it is 7 minus t. So from here, z is equal to 2 minus t plus 5. So that implies z is equal to 7 minus t. Correct, no, dear students? So let me write properly. So it is 7 minus t. Now we get z is equal to t plus 2 by 2 and z is equal to 7 minus t. So now let's merge these two. If we merge these two, then what we are going to get? We are going to get that t plus 2 by 2 is equal to 7 minus t. So t plus 2 by 2 is equal to 7 minus t. Correct, not dear students? From here, what we get? From here, we get that t plus 2 is equal to 14 minus 2t. As we get t plus 2 is equal to 14 minus 2t, so from here we get 3t is equal to 12, and finally t is equal to 4. So from here, what we get is that 3t is equal to 12, hence we get the value of t is equal to 4. So what are the values we got so far? We get the value of y is equal to 2 and t is equal to 4. The moment we find the value of t is equal to 4, then the value of z is not a big deal. Let me use a different color. Okay, so the moment we get so from here we can write z is equal to 7 minus 4, because the value of t we bring it here. So we bring it here. So from here, what we get? Z is equal to 3. So we get 3 values so far. Y is equal to 2, t is equal to 4, and z is equal to 3. Correct, not dear students? Now, all is remaining is that to find the value of x. That is not a big deal. Why? If we look into the equation 1, where is the equation 1? Equation 1 is equal to, now we can come to equation 1, and let me use a different color. So if we apply this value, so let's concentrate on this equation, that x equal to t minus y by 2. So here, what are the values of t and y we got? We get the value of t is equal to 4 and the value of y is equal to 2. So we are going to apply here. So what is the value of x we are going to get? 4 minus 2 by 2. So that implies we get the value of x equal to 2 by 2, which is 1. So we get all the values of x, y, z and t. I hope all of you understood, dear students. Anyway, after the class, I will share both the class note and this complete video lecture so that you can, follow and you follow in your at your comfort level and you find it out. So finally, dear students, what are the values of x, y, z, and t we get? We get the value of x equal to 1, y is equal to 2, z is equal to 3, and t is equal to 4. Okay. Whenever you get similar type of questions, you can solve it accordingly. Correct or not? Okay. So this is about the equality of matrices and how we can apply the concept of equality of matrices in solving problems. Now, I would like to conclude the class for today here. In the next class, what we'll be discussing on algebra or matrices, and we proceed further. We'll discuss that how we can perform the addition of matrices, then multiplication of matrix by a scalar, then what are the properties of matrix multiplication and difference of matrices, properties of matrix addition, and etc. Lot of things we'll be discussing and we'll continue in the next class. But before I conclude, dear students, I would like to tell you a very important piece of information. I'm going to share you another screen. Just stopping this screen and going to share another screen with you, and you are going to get you'll get that new screen in quite shortly, in few seconds. Let me share that screen. Dear students, I hope you are able to view the new screen now. If someone is not able to view, you can let me know. So I hope all of you are able to view it. Can one or two students confirm that you are able to view it?
Yes, sir.
Okay, great. Thanks. Then once you come to the website called www.konarclasses.com, you click on login. And in that login, all of you have your login and password. So I'm going to here with a demo login. And once you log in, then what you can do, dear students, is that you come to the Write Online examination. In the Write Online examination, you can type with here matrices. And you will see there are a lot of DPPs available. DPP stands for Daily Practice Problem. So I'll strongly recommend you to appear for these DPPs. So if you see, there are 18 DPPs. So every day you can appear 2 to 3 DPPs, and it will make your understanding very rock solid, and it will help you to make a fantastic score in your respective board examinations. Once the DPPs are done, so for example, if I go with one DPP, how it looks like, let me go to the DPP set 12. If you see here, first you get the instruction. What is that? Dear students, please note the following points before appearing the test. All the questions are mandatory, that is the point 1. And point 2 is that time duration for this test is 2 hours. And next one is very important. Please note that in this test, how much marks you are getting is not important. It is important how well you understand the concepts during learning and how well you are applying these concepts in solving these questions. So after that, what you can do, you can write test and you'll start getting questions, dear students here. Once you start getting questions, what you can do is that you can, upload your answer. And once, you can upload the answer, and after that, you can submit your paper. The moment you submit your paper, dear students, unless you upload your answer, so you need to upload an answer file here. So after that, for example, I quickly upload a sample answer file, and after that, you can just submit your paper. Once the paper submission is done, then it will be evaluated by our teachers. So once your DPP is done, all the DPPs, then you can come to the Write Practice Test. In the Write Practice Test, you just start with matrices. So you'll find, matrices here, Write Practice Test, and you start getting 10 questions in each and every practice test. And these are extremely important for your engineering entrance examinations. Karnataka CET, then IIT JEE Main, IIT JEE Advanced, BITSAT, and any other state level engineering entrance examination, this is very, very important. You can appear these questions. So how you will appear this question, dear students? Suppose, for example, I answered this as option A, this is option B, this is option A. Then question number 4, I give option D. Suppose question number 5, I do not know, I leave it. Then come to question number 6, I give answer B. Question number 7, I give A. Question number 8, I give D. Question number 9, suppose I do not know, so I didn't appear. And question number 10, I give A. Once all these questions are answered, dear students, what you can do, you can submit the paper. Once you submit the paper, you see this thing, paper submitted successfully. Your test result is mentioned below. Correct answer is 2, non-attempted is 2, wrong answer is 6, total marks is 10, and marks score is 2. And total time to complete the test is 0.59. That means 59 seconds, because I answered very quickly. And one important part here, dear students, is that please complete your self-assessment below by choosing the appropriate option based on your understanding. And here I would like to say you for few minutes, is that if you look into the first question, what is the correct answer? Correct answer is B. But the choice what a student make it A. Then the software, that online test platform, is asking 2 questions. The first one is that rate the question. How you rate this question? Suppose for you, this particular question could be very easy. But for some other student, the same question could be hard. So it is very important that you rate the question. Because rating that question will help you to understand, will help us to understand that what is your present level, and to make a success in your entrance examination, at what level you need to go. So for example, if you write the questions as very easy, then the second question, what is there, why it got wrong? We have observed a question get wrong because of 4 reasons. The first one is that did not study relevant theory. Second one is that concept was not clear. Third one is that silly mistake. And fourth one is that did not remember formula. If you notice also, dear students, that whenever you make a mistake to a question, generally it happens because of any of these 4 reasons. Either you didn't study the relevant theory, or concept was not clear, though you studied the theory but concept was not clear, or it is a silly mistake, instead of plus you have done minus, or you didn't remember formula. You know everything, but whether it is AQ plus BQ or AQ minus BQ, that formula you forgot. So you also write this thing. Suppose you write here silly mistake. Then what happens is that this online test platform, the software system understand, or this particular question, this type of question, you made a silly mistake. So in that way, you start doing for each of these questions. This is called self-assessment. The second one also, you rate the question. Suppose you rate as moderate. And why it got wrong? It got wrong because the concept was not clear. Come to the third question, suppose it is a hard question to you, and why it got wrong? Because you did not study relevant theory. Now, next come to the question number 4, is that, this question was a moderate question, and why it got wrong? It got wrong because you didn't remember formula. Then it is coming, the next one is that the correct answer is D, but you didn't attempt it. That's why it is N. If you recall, dear students, that, 5th question we didn't attempt. So first question it is asking is that you rate the question. So suppose I rate the question as hard. And the second one is that why not attempted this? Why you didn't attempt this question? We have observed, dear students, a question, when a student didn't attempt a question, that actually happened because of three reasons. The first one is that did not study relevant theory. Second one is that concept was not clear. And third one is that did not remember formula. Suppose I choose here concept was not clear. So all these your self-assessment inputs are actually getting registered in our online test platform. And later I will tell you that all this information are processed, leveraging our latest software technologies, what we use to give you meaningful information. If you look into the next question, question number 6, if you see, correct option is B, and I also got, the student also choose B. So then we are only asking read the question. So the student read the question as moderate. And the 7th question also, it is the correct option is A, and also the student choose A. So suppose this question is easy. Next one is question number 9, is that it got wrong. Question correct option is A, but the option, as chosen by the student is D. So again, the same two questions, read the question, suppose it is heard, and why it got wrong, because you did not study relevant theory, suppose. Then the question number 9, if you remember, dear students, 9th question also we didn't attempt it. So that is why it is shown as N. So first it is asking read the question. So I read the question as, moderate. And why not attempted this? So I didn't attempt this because I didn't remember formula. And the 10th question, what is coming, dear students? The correct option is C, and I choose option is A. So here also I read the question as easy, and it got wrong due to a silly mistake. Once this self-assessment is done, then what you should do, dear students, you should click into the submit self-assessment. Once you submit the self-assessment, what happens is that you get a message like this: your self-assessment submitted successfully. Your self-assessment will help us to guide you for a better preparation in more effective manner. We leverage artificial intelligence and machine learning extensively to make your learning and preparation more effective. Now, what we discussed, first you need to appear DPP, then you go for the practice test. After that, what will come, dear students? You come to the right online examination and then appear for unit test on matrices. If you type here matrices, then after DPP, below DPP, you will find unit test. You see UT, unit test starts with UT. If you click in this unit test, suppose if I click on unit test 1, set 1, so it says that it is a time-bound test, and it also has a negative marking. So what is that? The instruction is that all the questions are mandatory. For selecting correct option to a question, 1 mark will be awarded. For choosing incorrect option to a question, 0.25 mark will be deducted, and no deduction will be made for not attempting a question. Third point is that time duration for this test is 1 hour 40 minutes. So there are 50 questions which you need to answer in 100 minutes, that is 1 hour 40 minutes. After that, you click on write test and you start getting questions, dear students. And these questions are of great qualities and very important for different engineering entrance examinations. And you can appear this thing. So there are, each page you will get 10 questions. So as 50 questions, so there are 5 pages. So you see here page 1 of 5. Then you can go to the second page, page 2 of 5. Okay. Then you come to the next page, page 3 of 5. Then you go to the next page, page 4 of 5, and next one is page 5 of 5. So 50 questions. Suppose once it is done, then you can submit the paper and you get your score. I didn't choose any answer, so I got 0 here, as you see. Once all the UTs are done, then you can come to the right online examination and perform that for MDT. That is called module test. There are good amount of module test available, for algebra, MDT. If you see MDT, in mathematics, algebra, you will get MDT set, algebra 2 set 1. So algebra, trigonometry, coordinate geometry, calculus, application of calculus, 3-dimension geometry. These are different modules. Okay, so module test you should do once your unit test is done. Once all the module tests are done, then you go for the mock test. For example, how to appear for a mock test? You can go to the right mock test and you choose a paper. For example, you choose a paper, for CET, for example, you choose this one and start paper. Then you will get what? You'll see the question will be appearing in the left-hand side and you will get your question in the right-hand side, your options in the right-hand side. Okay, so this is the way you can, appear for the mock test paper. So this all what I wanted to say you. And I would like to conclude the class now, dear students. And again, we will have our class on Monday, where we will be starting, we will be continuing whatever we started discussing on matrices. We will be discussing on algebra of matrices. With this, I would like to conclude the class, unless you have any specific comments for me. Thank you very much, dear students.
Thank you, sir.
Thank you.
Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you. Thank you, Adilesmi.
Thank you, sir.
Thank you very much. Take care.